and welcome to section 8.6 of my college algebra book. And what this is going to be doing today is we're going to be talking about the binomial theorem and how to expand things like that. What they mean by binomial, first of all, is they mean something like, let's just give you an easy one here to start, x plus 2. That's a binomial because there are two terms, okay, just so that you are aware of the reasoning. In the past, you guys have done stuff like this, where it's just a 2, or maybe even a 3, where most of the times what you would do is write it out 3 times and start foiling it. Okay? You know, that's not uncommon for us to do that, or even if it's just 2, then we only have 2 of them, where foiling doesn't really take that long. However, now what's going to happen is we're going to give you the same binomial, but this time it's going to be to the power of, let's say, like 6. Then what do? Well, one of the things you could do is you could write it out 6 times and you could start foiling it, and you might be there a while. My screen would not handle this, so there is other options for you. There's 2 different ways, again, besides doing FOIL, that you could do this. One of them is brought to us by, I can't remember what nationality is, but it's from the mathematician Blaise Pascal, which is known as Pascal's Triangle. And here's how it works. He started by taking a 1 and 1 in these categories. Then what he did was he kept going with 1s on the outside, but he took 1 plus 1 to make it 2. 1 and 1 on the outside again. 1 plus 2 is 3. 2 plus 1 is 3. And he just keeps going. 4, 6, 4, 1, 1, 5, 10, 5. Oops, missed one. 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. A couple things about Pascal's triangle that I hope you notice is that it is symmetrical, which means that if I were to draw a line right down the middle, it's the same on both sides. But what this is doing is it's giving you the coefficients to have for your binomial expansion or binomial multiplying. And in this case, the only reason why I went down to row 6 was because my exponent was a 6. If it was the exponent of 15, I would have continued down with that triangle all the way till I get to the second number as a 15. So for this particular one, when the second number is a 6 and the exponent is a 6, this is the line that we're going to use for this particular problem. Okay, so I got to get a new slide to show that. So first of all, we have x plus 2 raised to the 6th power. Now going through and listing all those terms down there, we had 15, we had 20, 15, 6, 1. So those are my coefficients for that. Now, when you have a binomial, you have 2 terms. You have the first term and you have the second term. What I'm going to do is I'm going to take the first term on this first one and I'm going to raise it to the 6th power. And now I'm going to decrease the exponent all the way down until I get 0. So all I'm doing is I'm just subtracting an exponent every time. I'm going to put a 1 there just so that you see it. So that's the first term. The second term is going to work the other way. We're going to start at 0 and work our way up to the number 6. Now a couple things with this just to kind of give you an idea. If you're doing it right, the exponent should add up to be 6. 5 plus 1 is 6, 4 plus 2 is 6, 3 plus 3 is 6, and so on. These are all your terms. Now from here, you're going to simplify all of it. Anything to the 0 power is 1. 1 times 1 times x to the 6th would be x to the 6th. 2 to the 1st is 2 times 6 is 12. X to the 5th. 2 squared is 4. 4 times 15 is 60. X to the 4th. 2 to the 3rd is 8. 8 times 20 is 160. 2 to the 4th is 16. 16 times 5, or not 5, 15. Gotta get out my handy dandy calculator, I can't think of it off the top of my head. 240. And I'm going to run out of room here, so I'm going to have to kind of improvise here. 2 to the 5th is 32. Times 6 is 192. And 2 to the 6 is 64. So I'm going to just put that up on the top. So without having to FOIL everything, those are all my terms. I'm actually done. Now the reason why I left no symbols in between there is because I want to talk about this sign right here. If it's adding, we're going to put adding in between every single one of them, because we would never have a minus there if it's just if it's a negative. And I'm going to show you what it looks like in brown. If you would have had a minus in between there, then you would have had a minus here, add there, minus there, add there, minus there, add there. You would have had alternating signs is what would have happened. So that little trick with using Pascal's triangle actually goes pretty quickly when you get the hang of it. It's a whole lot of just multiplying just one term at a time and then writing it out as the whole answer. Saves a whole lot of time instead of actually, foiling that out. Some of you, if you tried to FOIL it, you'd probably still be foiling it at the same time. So just to give you another example of that. Okay, so first of all, what I notice is the exponent is 5, so I'm going to go to the one that has a 5 in the second number, which, if I go back a couple slides, it was this line right here, which is 1, 5, 10, 10, 5, and 1. So 1, 5, 10, 10, 5, 1. The first term in this column is 2, so I'm going to take 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 squared, 2 to the 1st, and 2 to the 0. The second term in this case is 3x to the 0, 3x to the 1st, to the 2nd, the 3rd, 4th, and 5th. Now when you're simplifying this one up, and I'm going to do each one individually here just to show you again, be very careful, because on the 3x part is going to be very tricky for a lot of people. But anyway, this whole thing right here, anything to the 0 power, remember, is 1. 1 times 1 times 2 to the 5th is 32. Then the next one. When you take 3x to the 1st, you actually get 3x. 2 to the 4th is 16, and a 5. So what I have to do with the numbers is I have to take 16 times 5 times 3. The 3 came from the 3x, so I get 240x. The next one, this would be 9x squared, because 3 squared is 9. 2 cubed is 8. So I end up with 10 times 8 times 9. And I end up with 720x squared. 3 to the 3rd is 27. 2 squared is 4. Times 10 is 1080 x to the 3rd. 3 to the 4th is 81. Times 2 to the 1st is 2. Times 5 is 810 x to the 4th. And then 3 to the 5th is 243. 2 to the 0 is 1 times 1 would be 243 x to the 5th. So now those are all my terms. Now it's time to actually write my answer. With a negative sign in between there, I'm going to alternate the signs. So 32 minus 240x plus 720x squared minus 1080x cubed plus 810x to the 4th minus 243x to the 5th. So again, using Pascal's triangle is just a way, it's a time saver. Instead of actually writing that out 5 times and foiling it, running the risk of multiplying wrong. I mean, you still have a risk of multiplying wrong, but it's not necessarily going to affect any of the other terms. It might just affect one term as compared to all of them. So that's the binomial expansion theorem, or not the, sorry, Pascal's triangle. The next one we have is the binomial expansion theorem, and basically what that is it's a way of, it helps, you can use your calculator a little bit to help you get going on it. First of all, the binomial coefficient is got a formula for you, and it looks like this. That is not a fraction. Okay, that's supposed to be n over r. That's not a fraction. What that actually equals is n factorial is how you call that. That's not n, it's n factorial. R factorial minus n times n minus r factorial. Now what factorial means is, if I were to take the number 5, for instance, like the last problem, it'd be saying 5 times 4 times 3 times 2 times 1. You know, you take the number it starts with, and you work your way down as far as all the way to the number 1. What this is doing is it's actually just a way of generating the numbers from Pascal's triangle. So for instance, in the last one that we had 5. 5 is the n, because that was the, so if I wrote the problem down again, since 5 was the exponent, then 5 is the top number. And then you simply start with 0, and then you would go to the 1, and so on. Now, doing it by hand, you do 5 factorial over 0 factorial, and then you'd have 5 minus 0 factorial. Now again, 5 factorial would be 5 times 4 times 3 times 2 times 1. On the bottom, 0 factorial doesn't really happen. 5 minus 0 is 5, so you have 5, 4, 3, 2, 1. And what happens is, instead of multiplying everything all out, just cancel things that they share in common, and I'd end up with 1. That was the first number in our row. If I do the same thing for the next one, just to kind of show you, 1 factorial, 5 minus 1 factorial, I'd have 5, 4, 3, 2, 1, 1, and then in the parentheses would come out 4, 3, 2, 1. And the reason why it was 4, 3, 2, 1 is because 5 minus 1 is 4. Now if I cancel out 1 for 1, 5 divided by 1 is 5. So all I'm doing is generating the same numbers that we got from Pascal's triangle. One of these things that if you look at it might help you get a certain one, but basically what I'm doing is I'm doing the same thing in Pascal's triangle, only this time I'm using a little bit different formula. On your calculators, that n over r is the same as NCR on your calculator. Where that's located is when you're using a TI 83 or 84, you go to Math, over to PRB, which is short for probability, and then if I think it's the third one down, it says NCR. When you want to use your calculator to do it, depending on the age, if you've got a newer 84, when you hit that button, it'll pop up like this, or then you just use your arrow keys and you insert the numbers. If you're using an older 83, then let's say if I wanted to do 5, 2, then I would type a 5, then I would go through this process over there so that it says NCR on your screen, and then type a 2 and hit enter, and it should pop up with the number 10. Okay. On the newer ones, then you put a 5 in here and a 2 in there and hit enter, and it should pop up with the number 10. So again, the binomial expansion theorem like that is just basically helping you figure out the same thing we did on Pascal's triangle, just using maybe your calculator instead of having the Pascal's triangle. I know generating the Pascal's triangle, I think in my lifetime I've had to go up to 30 or row 30, which takes a long time. But if you know the binomial expansion theorem, you could actually get to that row 30 pretty easily. You know, it's just a lot of number crunching. Now, The only thing that it might also do for you is it might say 2x plus y to the 20th, and it might say find the one that contains x to the 5th. So for that particular problem, if we're going to do x to the 5th, what we would do is, first of all, 20 would be my top, 5 would be my bottom. So I can do it all by hand, or you can use the calculator when you get that number. 20 factorial over 5 factorial. 20 minus 5 is 15 factorial. Then what would happen is that you would have 2x, because that's the first term, to the 5th. And now remember how I said earlier that the exponents would have to add to be the highest exponent, which in this case is 20. If you've got a 5 here, then this one should be 15, because it should add to be a 20. Now as far as getting this number from here, this is the same as 32x to the 5th times y to the 15th times, now 20 factorial is the same as 20 times 19 times 18, 17, 16, 15 factorial. And I'm going to explain why I wrote it like that. 5, 4, 3, 2, 1 times 15 factorial. Remember, if you've got something 1 for 1, all that's going to wipe away. Now, using some of what I've got left over, that would go down to a 4. This would drop this down to a 6. These two would drop this down to a 2. And then I don't have so much multiplying left to do, unless if I didn't have a calculator. So 4 times 19 times 6 times 17 times 2, and then don't forget the 32 from the other one. And I end up with 496, 128, x to the 5th, y to the 15th. So that's kind of one of the ways to use. If you wanted to find a specific term in there, that's kind of one of the things to do. But a lot of times we just basically ask for the expansion, which is the same as what we had for Pascal's triangle. The only thing is the binomial expansion theorem, that NCR is going to give you the numbers from the row that you would use. I would do the process the same. I wouldn't do anything different other than maybe use my calculator to get the row of numbers rather than writing out Pascal's triangle by hand. So anyway, thank you for tuning in.